Hi, this is Anna and Bella, and for our Cellular Automaton mini project, we were interested in researching how the introduction of electric vehicles in a traffic system can influence the overall flow and congestion patterns of the road simulation. So electric vehicles have the potential to help reduce traffic congestion because they have they're able to move more quickly through traffic because of their instant torque delivery, and they're able to accelerate quicker than gasoline vehicles. So we were interested in assessing how the proportion of gas versus electric vehicles can impact the flow of traffic in a road simulation. We did this by differentiating the two different states as the probability of accelerating at any given time and the probability of decelerating at any given time. So electric vehicles have a probability of accelerating every 70% of the time every time step, or 20% of the time every time step, decelerating. And then for gas, obviously 50% of the time they're accelerating and 30% of the time they're decelerating. So the design of our cellular automaton is a three-state system. The first state is no vehicle, that's empty road, no vehicles present. The second state, or the second type, is a gas vehicle. That's going to be marked with a G. That's a conventional gasoline-powered vehicle. And then the electric vehicle is the third state. The rules of this, the vehicles G and E move forward if the space ahead is empty. If a vehicle cannot move forward, it will check neighboring lanes, and if available, it'll switch lanes. And the vehicles have a probabilistic chance of accelerating or decelerating depending on their type. We're assuming that vehicles can only move forward or change lanes, so we're ignoring turning and reversing, and the probabilities for accelerating or decelerating are fixed. So as time goes on, you're not going to see the odds of accelerating or decelerating change. The road also has no entry or exit point, so as cells move towards the right, they're going to just wrap right back around. So we were interested in seeing if we change the density of gas versus electric vehicles, how this would change the average movement rate. So you can see the electric vehicles are given in green, the gas vehicles are given in red, and the total average movement is given in blue. And this is kind of the line that we're going to use to compare the different simulations. Just to give you an idea of what each simulation looks like, here's an example. So this is our test for how traffic flows when the density of gas and electric vehicles are the same. For every run of this simulation, we had a total density of 20%. So 20% of the road is covered by some vehicle. So it's a 50 by 100. So this is a 50 lane highway, which might be a bit excessive. But this is what the simulation looks like. So you can see at each time step, they're inching forward. And depending on their rate of acceleration or deceleration, or depending on if they have neighbors, that influences their movement. So we'll just let that run for a minute. And then once it hits 100, you'll see this graph pop up. So like I said, this is the average movement rate at each time step for each gas and electric vehicle, and then the total up here. So we ran that for a density of 15% gas and 5% electric, and then reversely for 15% electric and 5% gas. And I was interested in seeing, my assumption was that the electric vehicles would help improve efficiency, but actually what happened, if my computer let me scroll, is that you can see here with the slope of that regression line, when there was equal density of gas and electric vehicles, we had the vehicle's total movement rate pretty low compared to when there was more gas vehicles and electric. We saw that number increase quite a bit. So the overall movement rate of the vehicles increased in the scenario where there's more gas and electric, but we also saw it increase in the scenario where there's more electric and gas. So that told us that if there is an imbalance in the density of vehicle type, so whether there's more gas versus electric or more electric than gas, then the congestion rate and the amount of movement on a roadway is better than if there's equal amount of gas or electric. So in future studies, I'd be interested to know how the total density of the roadway, instead of just 20%, maybe 40% of the road, or if we have full traffic, traffic jam system, how does the density of electric versus gas impact those scenarios? Also, this simulation had no on or off ramps, so no entry points or exit points. So I don't know how those could have impacted this simulation as well. Also, obviously, we had a pretty big highway we're looking at, a 50-lane highway. So perhaps changing those parameters could change the results of this study as well.